Chapter 5, Section 5.3 Isotopes. In this section, you'll be able to learn how to define isotopes. Let's look at isotopes of hydrogen. Hydrogen, there are three different isotopes here, three different atoms. There's hydrogen 1, hydrogen 2, hydrogen 3. If you look carefully at the nucleus, which is the center of the atom, you notice that the number of particles in the center are different. Okay, so let's look at this. What are the particles representing? The green color is a neutron, the purple color is a proton. So each has one proton. Because we mentioned before, the number of protons is actually unique to the type of element. So hydrogen all must have the same number of protons. But hydrogen 1 has no neutron. It has a mass of only 1 because only one proton itself, so the mass of 1. That's why hydrogen 1. But hydrogen 2, one mass comes from the proton and one comes from the neutron. So the total mass of these two particles is relative mass is 2, so hydrogen 2. And you realize that in the third hydrogen, hydrogen 3, there are three different particles inside there. There are two different particles inside there, but there are three numbers. There's one proton and then there are two neutrons. So altogether three particles. And each one has a relative mass of 1. So this hydrogen 3 has a relative mass of 3. Number at the back actually represents the number of particles in the nucleus, which is the mass number. So what are similarities and differences between these three atoms? To recap, hydrogen 1 has only one proton. Hydrogen 2 has one proton and one neutron. Hydrogen 3 has one proton and two neutrons. So that's the differences between them. And of course, similarity is that they all have only one proton each, but they have different number of neutrons. Similarity is same number of protons, and the difference is different number of neutron. Okay. Now, so what are isotope? Let's define isotope. Isotopes are atoms of the same element with the same number of protons but different number of neutrons. So the three phrases you need to remember is they are atoms of the same element and the same number of protons, different number of neutrons. Let's look at an example here. Chlorine, the symbol chlorine is given as 3517 and 3717. So what happens is that they both have the same number of protons. So they are 17 proton, 17 proton. But the mass number on top is different. One is 35, one is 37. So if you take 35 minus 17, 35 minus 17, you have 18. So you know that this has 18 neutrons because the total added together, this is the mass number. Mass is equal to 35. Now for this 3717, you take 37 minus 17, you realize there are 20. So 20 belongs to the neutron. So there are 17 protons based on the proton number. And you take the mass number minus the top number minus the bottom number, you get the number of neutrons. So in fact, they all add together must give back the mass number 37. So these two are isotopes of chlorine. They both have 17 protons, but chlorine 35 has 18 neutrons, while chlorine 37 has 20 neutrons. And in fact, chlorine gas in the atmosphere is 75% of chlorine 35 and 25% of chlorine 37. So they are more abundant chlorine 35 as compared to chlorine 37 in a ratio of 3:1, 75% to 25%. Now, an example here is an isotope of carbon. Carbon has three different isotopes. They call it carbon 12 by the mass number 12, carbon 13 by the mass number 13, and carbon 14 by the mass number 14. So, what are the differences or similarity? The similarity is that they all have 6 protons each. Because as long as they're carbon, the carbon atom, they must have same number of proton. But the number of neutron is different. So you take, for example, the first one, 14 minus 6, you get 8 neutron. Okay, 8 neutron. Second one is 7, because 13 minus 6 is 7 neutron. And 12 minus 6 is 6 neutron. So they have different number of neutrons. But they must have same number of proton. So let's define isotope again. Isotopes are atoms of the same element, in this case carbon. They have same number of proton, which is all 6 in the carbon, but they have different number of neutrons. And you need to remember the properties of isotopes. Isotopes have the same chemical properties but different physical property, and this is so very important. Now, why same chemical property? Because any chemical reactions must be due to the electrons. Only electrons, specifically the valence electron, which you learn later. Valence is outer electron in the outer shell, the last shell. They're involved in chemical reactions. Alright? So all the chemical reactions are involved by the electrons only. And they have different physical property. Why? Because they have different relative atomic mass. The different atomic mass is due to the different number of neutron. Okay? The number of neutron different means the mass different, and the mass different, you realize that they end up having different densities, different melting and boiling points. Uses are isotopes. Isotopes that emit high energy radiation are called radioisotope, and these are called radiation. Okay, the radiation given out. So they are radioactive substances, and the radiation emit is dangerous because it can damage living cells, and of course it can cause cancer. However, radioisotopes can have important application and can be safely used if they are handled properly. For example, smoke detectors, they use radioisotopes. Alright, so when the smoke enters the smoke detector, it absorbs the radiation, and because it absorbs radiation, it can set off alarm in the smoke detector. By the way, this is not very important, just need to know that there's such thing as radioisotope. Okay. Now, arrangement of electrons in atoms in section 5.4. You will learn how to use diagram to describe atoms containing proton, neutrons in the nucleus, as well as electrons arranged in the electron shells. They're outside the nucleus. As we mentioned earlier, their energy levels actually. The electron shells are actually imaginary path where electron move, and these are different energy levels where you can find the electrons. So electrons move around the nucleus in regions known as the electron shells. Take note of this term, electron shells, and these are all imaginary path. Okay, this is an electron shell, imaginary path. There's no physical path actually. So in the first shell, which is closest to the nucleus, there's a maximum of 2 electrons that it can reside in this shell, and it's always to filled first. Alright, it has the lowest energy level. So the closer you are, the lower you are the energy level. So the lowest energy level is 2 electrons in the first shell. In the second shell, it can go up to 8 electrons maximum in the second shell. So first shell, you take note, this first shell, there are 2 electrons. And then you realize on the second shell, you have 8. It's higher energy in the first shell. And the third shell is up to 8 electrons also. Okay, you only can go up to the third shell after you fill out the second shell. You can only go to the second shell after you fill out the first shell. So the filling out shell is always like this. First, second, third. For example, you have 3 electrons, you put in 2 and then 1. Okay? If you have 10 electrons, you put 2 and 8. Total is 10. But if you have 12, you end up having 2, 8, and 2, because altogether you have 12. So first you fill out the first shell. When it's completely filled up to 2, then you go to the next shell, maximum 8, and whatever balance you go to the third shell. That's how you do it. So the maximum for the 3 shell is 2 first shell, 8 second shell, 8 the third shell. Once third shell is filled with 8, you go on to the fourth shell. Now, electronic configuration or structure is the arrangement of electrons in an atom. How they arrange? For example, in this case, magnesium atom, it has 12 protons and 12 neutrons. So what happens is that you can even draw a box like that. So 12 altogether, 12 proton. So the first shell you can fill up to 2 maximum. Second shell, the remaining, you can put second shell. 2 plus 8 is 10. But there are 12 to go, so it's 2 more at the end. So it's 2, 8, 2. That's how it looks like. First shell, 2, second shell, 8, and the third shell is 2. So configuration can be written as 2, 8, 2. Now the valence shell or the outer shell refers to the shell that is furthest away. So the valence shell or the outer shell, which I mentioned earlier, the valence electron, whatever, valence shell and outer shell is the furthest away from the nucleus. And the valence electron are the electrons found in the valence shell. For example, in this case, the valence shell is the furthest from the nucleus, furthest. And the electrons that is furthest away, okay, they are called the valence electron, furthest away. So magnesium has 2 valence electrons. The configuration for magnesium, which is 12 proton, we just now learned this. 12 proton will be as good as 2, and then second shell maximum 8, and then remaining go to third shell 2. And that's why you have 2 valence electrons in the last shell. So the last number is the number of valence electrons. So the chemical property depends on the number of valence electrons. Because chemical property means the reaction. Reaction occurs when a valence electron either give away, or they take in, or they actually share valence electron. So for example, sodium has a 281 configuration. Potassium has configuration of 2881. Now do you realize that the last number, which is the valence electron, are the same? They each has 1 valence electron. Since they have same number of valence electron, they react similarly, similar chemical reaction. So the next example, fluorine is 27 because fluorine has 9, proton number 9p, and chlorine has 17p. So the configuration is 27 for fluorine, 287 for chlorine. Now look at the last number. Just look at the last number. Last number is the number of valence electron. They both have 7 valence electron. Since they have same number of valence electron, they react similarly. Similar chemical property means similar chemical reaction. They react similarly. So how are the atoms arranged in the periodic table? So the elements of the atoms are arranged in the order of increasing proton number. So the elements are arranged in the increasing proton number. Okay, look, proton number 1 for hydrogen, 2 for helium, 3 for lithium, 4 for beryllium, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon is 10. So you go by the first row, and then after the second row, and then third row, and so on. So it's always from left to right in increasing order of proton number. Now look at configuration. Let's look at just randomly look at phosphorus, 15. 15, the first shell maximum is 2, second shell is 8, so the third shell is 5. So you realize that phosphorus and nitrogen, they both have 5, that's why they are both in the group 5. Do you realize the group number? Group number 1, they all have 1 valence electron. Take note of that. Group 2, in this Roman numeric 2, 2 stroke, 2 capital I, 2 valence electron each. And group 3, 3 valence electron. Group 4, okay, 4 is IV. IV is a Roman numeric for 4. There's 4 valence electron, 4 outer electron. Group 5, 5 is V. Okay, this 5 is V, so it's 5 electron. 6, Vi is 6. So this actually is 4, 5, 6. Okay, when it asks you for group number, you cannot write the normal kind of mathematical number. You must write the Roman numeric, which is the V, IV, and so on. So 6 outer electrons, group 6. 7 Roman numeric is VII. So there's 7 outer electron. And the group 0 actually is helium is 2 outer electron because it has only 2 and only 2. But the rest are all 8. You realize that. Now take note, the group number, the group is actually the vertical column. So group 1, 2, 3, 4, 5, 6, 7, and group 0. But the period number is actually the row. Period is a row. 1, 2, 3, and so on. Alright? So the horizontal row, which you just mentioned, is called a period. So this is the first period, second period, third period, and so on. Okay, so you call it period 1, period 2, period 3, and so on. Now the vertical one will be the group. Vertical column is called the groups. Now put a star means you must memorize lah. Okay, so the vertical column is like this: group 1, group 2, group 3, group 4, group 5, group 6, group 7. Okay, and then this is called the noble gas group 0. Elements with the same number of valence electron belong to the same group. As we mentioned just now, same number of valence electron, which is the outer electron, the last number, they all belong to the same group. For example, sodium 281, it must be the same group as potassium group 2881. All belong to group 1. Alright, capital G, and then this is a Roman numeric. You can write as a capital I. Now 7. Fluorine is group 7, chlorine group 7 because they both have 7 valence electron. Okay, it's VII, group 7. This represents 7 in Roman numeric. And hence, since we mentioned just now that when they have same number of valence electron, they react similarly. So you realize that elements in the same group, they must react similarly. They must have similar chemical property. Why are elements in the same group having similar chemical property? Because they have same number of valence electrons. Okay, because of same number of valence electrons. Okay, so the number of valence electron determine the reaction. And since they all in the same group must have the same number of valence electron, they must all react similarly. It's only how fast or how slow, but they all react similarly. That's all for the topic. So this is a summary. Atoms consist of the nucleus and the electron shells that's outside the nucleus. In the nucleus, there is a neutron and proton particles inside there. The only exception is hydrogen. Hydrogen has only one proton. There's no neutron in hydrogen. Isotopes. Isotopes are atoms of the same element with the same number of proton, but different number of neutron. In any chemical symbol, alright, you write AZX. For example, okay, let me give a real example. Let's say sodium 23 Na11. It simply means the X actually is a symbol which is Na for sodium, and the Z actually is a proton number which is 11 for sodium. Sodium is 11 proton, and A represents the nucleon number which is 23, and 23 is the number of proton plus neutron for sodium. Atoms are always electrically neutral. Why? Because there's always equal number of proton and electrons. These two must always be equal. Alright, I repeat. In any atom, the number of electrons and proton must always be equal. So if the number of proton and electron are equal, the number of proton is positive. For example, 10 proton, that means plus 10. And then 10 electron, minus 10. So since they're equal number by opposite charge, so they cancel each other, and atoms are always electrically neutral because proton equal to electron. And the arrangement of electron in the shells is called electronic structure. Take note, the first shell is maximum 2, second shell maximum 8, third shell maximum 8. Okay. Also take note of the special property of the proton, neutron, electron. Look at neutron. Neutron has a mass of 1 and a relative charge of 0. Proton has a relative mass of 1 and the charge of plus 1. And electron has a very, very tiny mass, which is 1 over 1840 by its charge of minus 1. Okay. And then the last thing need to know is the outer electron or valence electron. They are the electrons that are found in the outer shell, okay, the last shell. So the valence electron refers to the last number in the electronic structure or configuration. The last number is the number electron in the outer shell. That's all for this topic.